Hey guys, welcome to my channel. Today we're gonna do a LeetCodeHub problem, and this problem is from the uh, bi-weekly contest 86, and it's the last question, which is the maximum number of robots within the budget. And what the question describes is it gives you two arrays that go the same size, and each represent so each index represents a robot. So there's charge time and running cost, and the total cost would be the maximum charge times. So so total cost for running k chosen robot, and the k chosen robot have to be consecutive, and the total running cost for that k robots would be the max charge time for those k robots, and k times the sum of running costs for those k robots. And we can have a look at this array. It gives you 5 robots here, 5, which in each index represents the charge time for each individual robot, and here run time for the 5 individual robots. And we want to choose the maximum consecutive k robots such that the total cost wouldn't be exceeded the budget. And here the output is 3. That's because we can choose the first 3, and the maximum charge time would be 6, and the running cost, the sum of running cost will be 6, and 6 times by 3 equal to 18, 18 plus 6 equal to 24, and 24 do not exceed 25. So it's possible to run more than 3. It's possible to run 3 consecutive robots, but there is no 4 robot, and that's how this question described. And from the question, there's some interesting things. So at first, it's like consecutive robots, so that we know there have to be a subarray, right? And since it have to be a subarray, then obvious idea is using two printer, right? Because two printer is ON. And but for this problem, there's also one interesting thing. Is like you have to track both the maximum number of chat times and the running sum of the running cost, right? For given an interval, you have to know the sum of this interval, and you also want to know the maximum among that interval. And to do so, I will talk about that later. But that's not like complete idea right now. So if we're using two printer, we have to think of cases well when we're gonna expand on the right and when we gonna shrink on the left. But for this question, you don't have a good way to do that. So the actual solution is to use also combine the binary search idea on this sliding window approach, which is let me just ignore those two, and let me just make a simple diagram. So suppose that the robot have this n elements. Well, it's very hard for us to how to say it, like for us to find the sliding window method, which is like I and j, and then sometimes we shift j and sometimes we shift I. It's pretty hard. I'm not sure how to do that. But to simplify the idea, if each time we want to verify a fixed length, then the whole problem becomes much easier. What I mean by that is that suppose that in this case you only want to verify size 2 sliding window, so that we can have a sliding window like this, and then we just keep moving it to the right. And it's very easy for us to do that if we know the size of array. But how do we find the final size? Which obviously we want to find the maximum. So we want to find the maximum length subarray such that the above cost is below the budget, right? Then we can utilize some binary search idea. So we set our minimum to be 1 because it doesn't make sense you want to set. Actually, wait, it makes sense you want to set to 0. Then 0 is like obviously return true. So our min will be 0 and our max will be n. And for each time we take mid, which mid will be equal to 0. Let's just do it like this. So min equal to 0 and max equal to n. Then we do a binary search. We do a mid equal to min plus max and divided by 2. By divided by 2, and then we verify if this subarray can if there is a chance that it can support a side of mid sliding window. So we will be testing if there exists a sliding window that satisfies the budget within the mid side. If it is satisfied, then obviously what we're gonna do is to make shift min equal to mid plus 1, and then we keep doing that. Or alternatively, we will be doing max equal to mid minus 1. If that doesn't satisfy, then we just search on the longer range. Actually, here I think so yeah, actually just forget about it. It doesn't matter, just binary search like specific case. Yeah, but that's the idea, and still we have to so they simplify our problem by finding a sliding window solution to finding a fixed sliding window that could run in ON time. That could run in ON time. We still want to run to efficiently, right? But it's like simplified because it's not fixed length. And we will do the maximum log because we're doing binary search, right? So we will be perform maximum log those operations. So finally, our final complexity would be log times ON, which is ON log, and yeah, that's the discussion for our efficiency. And let's have a look on the code. So here, that's what I've been doing. So we set minimum and we set maximum, and we just do binary search, and we'll use a helper function. And what helper function do will be take this to array, right? And then it take the budget also, and also take a size. And what it does is to verify if the size mid subarray if there exists a size mid subarray that do not exceed the cost. That's what this helper function will do. And then we will be working on our helper function, and I haven't finished it, but we're gonna finish it together. So to solve this problem, so for the same let me just delete it. So what we need is two things, right? The first thing is we want to always tracking the maximum size maximum int around this interval of the chat times. And the second thing we want is the sum of the rounding cost. And sum of rounding cost is very easy. You just use the int and keep updating it. Nothing about it. We consider about this. Chat times, how do we represent the maximum element in an array? And how do we do so is to basically we will be using a dict, and what this dict does is we always perform is that we always insert number at the back. But while we insert number at the back, we also will pop out those number that is pop out of those number from back that is smaller than inserted number. And what this does, so what this does is that we can consider a small case here. So suppose that we want to our dict have original have like 1, 2, 3, and then we want to insert a 4. And in normal case, that what we can do is that if we want to do it in no efficient way, then we can just pop out this element 1 and add this element 4, and maybe we do a search, right? And then we see 4 is the maximum number, and that's end of story. But dig does is that while we inserting 4, we can actually discard the above 3 element. That's so think about why. So we so original job is array, right? So let me just put this array. Just like make it more authentic. Okay, cool, like this. And suppose that this is given array, right? And then we are doing sliding window. So from the diagram, we can see that our sliding window have this range. And then we want to shift it to here to add 4, right? And suppose there is also element after 4. So let me just add some random element. It doesn't matter. Cool. And then we want to shift our sliding window like on the right? So all this element will be pop up before our number 4, which is the number we want to add to our queue. So that, and also there's another thing is like 4 is greater than all those numbers, so those numbers can be ignored. Those numbers wouldn't have any effect to the rate that involving 4, basically involving this greater number. So but this number will be like last longer than the above number, so we can just pop out those number because they wouldn't have any effect to our maximum for this interval. And yeah, that's the idea. And then we can start to do it. So at here we have a run sum and we have a dig, which also we want to because we want to support two operation. One is to insert the back, pop out the back, and also we want to pop out in the front because we still want to update it for the interval. And for the sake of interval, so if you want to track both, so our above discussion is about the size, right? We want to pop back those numbers that have like smaller size. So there's another thing we still need to track is the interval, right? So we also need to store index, but we can actually store those two together. We just store index, and by index we can find its value from the chat time. That's the idea. So we only need the int. And cool, and we can start working on it. So we are just using a bigger for loop. Size. And here we have two cases. If I is smaller than size, then what we do is just sum plus equal running cost. Running cost I. And then we want to do some operation on our dig. And that's what we're gonna do. So let me think about it. Should we just insert and don't care about anything? And we can do some updating here. So I'm not sure if it's a good idea or not. Let me think about it. No, I think it's like so. Let's do update way. So we want to pop out those elements. And here we can make another annotation that those elements has index smaller than I. It's like a key observation for our algorithm to be work. And what we do is that while deq.empty equal to false, so it's not empty. Yikes. And dig.back and this charge time is like smaller than charge time I. Then we do a dig.pop back, I think. Let me search it. Dig. Yeah, I think it's pop back. So Pulls good. And we want to insert new element, which is I, and here we will do dq dot push back I. Cool. And the other case will be we want to actually perform sliding window. So first thing first, we calculate the sum. Or not sum, just current cost. And current cost will be our dec 0. So let's do the int maximum charge equal to dec 0. And also the budget is just sum. So long calculate budget would be equal to budget would be equal to maximum charge times by size, plus size times by our sum, right? And if calculate budget is smaller than budget, I should be smaller than equal, I think. We return true. And obviously after all for loop, if it didn't return true, then we should return false. Then we update it. So all we're gonna do here is that sum plus equal to running cost I, and then we want to sum minus equal to running cost I minus size. And this is true because it's like I smaller than size. So here it's like I at least greater equal to size, and for equal to size case, we will deduct the index 0. So it should work. Then we update it, and beside update, we also need to update it. We also need to sort of, let me think about it. So yeah, we also need to update Q. Then what we're gonna do is the same. We do this, and also we want to do one more step, which is while dec empty equal to false and dec 0 is like smaller than smaller equal to I minus size, which this means that it's out of interval. Then what we're gonna do is dec dot pop front, and that's the two operations we need to do. After those two operations, we as usual we push back our I, and that's our sliding window. And let's run it. Compare arrow. Times. Oh, I made a few mistakes. Then 15. Right. Runtime error. Addition of onside of. Okay. So here, if I estimate the size, then So take that back. I'm not sure what does it return, so let me just have a look. So return reference to the last element to the container. Okay. And iterator return. Oh, I realized. So I saw the dot-bags were them. It's a stupid mistake. Select this. Okay, it returns 2. So you can do this. So here would be I not equal to j and then return I. Okay, it's not working. I'm not sure why though. Well, show him I made -1, I think. I think nothing wrong with this. About it. So at this case, but this case, then she'll explore what's wrong. Okay, I might to do with my mid. So let me just resume it back. I'm just 4. Unequal. Should be smaller. Here should be smaller equal. Okay. Also here I need to add something, which is if size is equal to 0, then we'll return true anyway. Well, shouldn't be 4. I don't. Great. I'm not sure what's the problem right now, so if the helper, if it works, then we increment I. If that doesn't work, then increment j. So it's like an interval, and it gives 4. 4 makes that. Wait, let me just see out I and see why success. Oh, maybe I should. Yeah, I'm writing I, so. I'm sorry. I say I'm So what I should do is I should return mid. Myself 4. So equal to smaller than I. So work for 1, and here shouldn't be working. 12. Oh, I realized my mistake. So it should be chast time because I'm storing index. That's actually a stupid mistake. Right. And they're testing a few more cases to see if it's actually working. It seems working. Okay, that'll work. So what should be? Oh, this might be crazy, but that amount. Oh, I need to. No, I don't think it's because of this. So. Shut up. So I just 7, but it should be 9. I think it's to do with I didn't test the last case, so let me just put one here and it should solve that problem. No, it doesn't solve the problem. Oh my gosh, I realized my mistake, yeah. No man, it's not my mistake. Oh, so I saw my mistake is I didn't do this, but I did. What? What's my mistake? It's a freak. I don't get it. I don't get it. So here it should be like So at this step it should be so like in this else branch, then it should already have a set subarray, and so that I make perfect sense for me to calculate first and then update it. Freak. I couldn't think of the reason. I can do it. You realize it does nothing, right? Maybe I should do this step first. Maybe that's the reason why it doesn't work. Okay, it's not. So I think I didn't pass 8. It didn't even pass 8. I don't know why it didn't pass 8. Well, let me just do it here. So I'm gonna do it here. Yeah, let me do it here. Okay, it didn't get printed out. Why is that? Freak. Freak! Small equal. Oh, so not true. I just realized something. Here, resume recording, and here I fix my problem. So I realized that the first mistake I made is that I do j equal the size -1, which but it doesn't represent the index, actually represent the size. So that's a mistake. That's my first mistake. And the second mistake is that it should be small equal. Yeah, that's my mistake, and it should work now. Let me just delete my C out and we'll just submit. What time limit? Oh crap! I think it's because I'm doing C out. That's why. Yeah. If I delete that, then it should be fine. Do not submit. Cool, it worked. And we're doing fine. So yes, thank you for watching, and see you guys.